Okay, so today is probably dealing with one question on your diploma, okay? And you know what? Let's face it, that we may do a day that they don't even pick that question for the diploma, right? Because if it's 40 questions and we do, 100 different topics, they can't pick them all, right? And sometimes you need to know 3 different topics to do one question, okay? So they will probably give one of these, and they're called basically like half-life questions or doubling life questions, okay? Yes, let's make sure phones are off. Now, I want to actually just go to the next page. Okay, and we're going to title these like, half-life, double life. Yeah, you can have triple. Okay, now, what's neat about this, or cool about this, is that every element on the periodic table has what's called a half-life. And there is no 2 elements that have the same half-life. Now, what does half-life mean? It means that if you leave it, there's a certain number of days and sometimes years before it becomes half of what it is. Okay? And from that, they can tell you exactly what it is without even doing any chemical composition. The other thing is called the double life or doubling time, is that there's many different types of bacteria. Okay, so if you have strep throat, the doctor will do a swab, and then he puts it on a petri dish. Now, what I used to think is they put it on that, and then they wait a couple days, then they put it on the microscope, and they go, oh, look, it's that kind of bacteria. Okay, but they don't. They see how many, they count how many, right? And then they come back and see how many are the next day, and they can find out it's doubling life, and they can identify the bacteria, because every different type of bacteria doubles at a different rate. And that's how they can tell its personality. That's how they can tell the exact type you have. So that's how they know what medication to give. Because often if you go to the doctor and you do have like strep throat or something, they don't just give you meds right away. They'll do a swab and then they'll call you. Okay? So they just swab your throat and they rub it on a petri dish, and it's like an agar stuff, and it grows because it's food, right? And from that, they know exactly what it is. They'll give your pharmacy a call and they say they need this antibiotic. Okay? So that's why I'm sensing that they always give one of these, because, it's something that is done in chemistry and stuff too, that, they always want to try to make real life examples on the tests and everything. So these half-life, doubling life, triple life, to be honest with you, this is all that is covered in chem, is half-life and double life. They may say, oh, it triples every 5 years. That's just to make a question, right? But you wouldn't see that in, bio or chem or whatever. So we're going to go through this example, and with this example, I'm going to teach you all the different parts of this. Now, the example, I actually just want to grab a formula sheet of yours to make sure it's on there. With all my different courses, I forget which formulas are on. Okay, I do not see the half-life or double life formula. Okay, so this is something they just may give you, and then you have to kind of figure out what is this about. Now, let's read the question. It says the radioactive element cobalt-60 can be used to treat cancer patients. Radioactive elements decay into other elements in a predictive way over time. So that predictable is its, half-life, right? The percent of cobalt-60 AT left in a sample can be modeled by this half-life function. Now, because it's half-life, that's where the half comes in. Okay? So this is the half-life. If it was doubling time, there would be a 2 inside there. If there was tripling time, there would be a 3. Okay? And here is the, see this little fraction here, or at the bottom of this fraction and this entire thing. These two are always together. This means the half-life is 5.3 years. That means every 5.3 years, I don't care how much, if there was 20 grams, in 5.3 years there will only be 10 grams there, okay, of cobalt 60. It will be half in 5.3 years. Now cobalt 80 may take 5.8 years. That's how I know the difference between cobalt 80 and cobalt 60. I just don't go and I don't know what you're thinking. You think, oh, do you have to wait like 5.3 years? No, you can use this formula since you already know, well, it's either cobalt or it's, you know, cobalt 80 or whatever. You can use this formula to figure it out. Now, what is this A? This means A naught. Okay, A0 means right now. So this is always your initial amount. Okay, now this T up here, this always stands for time observed. Okay, so how much time went by, or this is how much time I saw went by. And then this is the amount after time t. Okay, which is this t right here, the same one. Okay, so if I want to know, well, how much will there be after 8 years, I'll put an 8 up there to find that out. Okay, so when we do an example, so this is time after, this is amount after time, which we call t, like, I don't know, 5 seconds, 2 hours, 10 years. Okay, now, let's do a question. It says, how long does it take for a sample of cobalt 60 reduced to half its initial amount? Now, we want to use AT equals AO, A naught times 1/2 T over 5.3. Now, why am I using T over 5.3? Because it takes 5.3 years for cobalt to reduce to half. Remember, these two, it's like a sentence right here. Half-life is 5.3 years. So I always circle those two. Okay? Always, always, always. Every question I do, I circle those two and I go, okay, the half-life is 5.3 years. That's what that means. Okay? Now it says, how long does it take to reduce to half its initial amount? Now, that's kind of weird because we don't even know how much we have. Like, how much do we have right now? It doesn't tell us, but you can pick any number, and then A naught will be now. A after time should be how much? Half of that, right? So you can pick any number. Like if you put 100 here, right? 100 is how much I started off with. What would be the amount after a certain time? This should be 50, correct? So you can pick, you could call this 2 to 1, right? You could call this 200 to 100. Do you see how they're all half? All of these are half what we started with. Oops. Okay? So this is the most common one though. Okay? Or these two. Sorry, these two are the most common. I mean, you could put 7.8 and 3.6 if you want. That's just weird though, right? But as long as this number is half of this, because that's how much. Now, and don't get this half reduced, mixed up, right? This is the half-life is 5.3. So there's kind of two halves going on, which gets confusing. Now, once I have those, and I'm going to finish my formula, oops, 1/2 t over 5.3. Now, if we think about this, well, let's just do some math. The first thing I need to do is I got to start, like this is an exponent. I hope I'm not writing it wrong. This is supposed to be an exponent, t to the 5.3. Okay. Now to solve this algebraically, what's the first thing I need to do? Because I got to get t by itself. Any guesses? We want to get rid of this 100 in front. So we need to divide by 100, divide by 100. So this equals 1/2 equals 1/2 to the t over 5.3. Okay, now what's the exponent on here? No. There is a 1 there, correct? Now once the bases are the same, what can I do with them? So then I can go 1 equals t over 5.3. So what do you think t is? What's the time that it would take this to go to 1/2? Yeah, because I would multiply both sides by 5.3, and I would get 5.3 equals t. Now that should make sense. If it halves in 5.3 years, should it take 5.3 years to get to 1/2? Okay, so that's why we thought we would start with this one. Okay, now the diploma is not going to give you one like that. Okay, but they will give you something like this. It says what percent of cobalt 60 will remain in a sample after 10 years? Round to the nearest percent. Now when they don't give you what you have now, you can always be safe by saying how much do you have now? What percent? You have 100% right now. Okay? So I need to find, here's my formula, AT equals, and they might just give you this in the diploma, 1/2 to the t over 5.3. And hopefully you look at that and you go, I have no idea what this is, but I know what half-life's every 5.3 years, right? Because remember, we draw that circle, and we can always make this sentence. Oh yeah, the half-life is 5.3 years. Now, this always gets students a little bit confused because it's so, efficient. But this means amount after 10 years. Now, you can't solve anything on this side, but this is what this means. Amount after 10 years equals, well, what amount did I start with? You look back, it doesn't even say. Sometimes they'll say you got 32 grams. Put it in 32 grams. But they don't tell me anything. So that's where I'm always going to put 100, as in 100%. Okay, and maybe you just want to put a little arrow here, 100%. That's what that really means. Not, you're looking around, 100. It didn't say we have 100 of anything. What is he talking about, 100 grams? Right, 100 mils? Like what? Then we go 1/2 to the, now what always goes up here? The time that this thing is rotting away. How long is it rotting away for? So we go 10 over 5.3. Now is there any math to do on this side? No, and some students think, like, do I have to take a and multiply by 10? No, this is a way of writing the amount after 10 years. Amount after 10 years. That's what this means. Okay? It's like you're trying to take mathematics language and be able to make it into English. Okay? That's what that means. So now we need to put this in. Make sure this is an exponent, and make sure you put your exponent always in brackets when there's more than one thing. So what would that look like? I'm just getting out of here. I'm going to clear this screen. And you would go 100 times 1/2. You don't even have to use a times sign. Your calculator is smart to know. Okay. Then I'm going to do the exponent, 10 divided by 5.3. Okay, it's really, really important that you always put, oops, what did I do? Yeah, that you always put your entire exponent. See, here's my entire exponent. This is my exponent. You must put all of it in brackets. Okay, then you hit enter. Is that 27 years? What is that? 27%. Very good. Because 10 was the years, right? It's the amount after 10 years would be 27%. Okay? Now I'm just going to take a screenshot of this so when students want to look back, they can see how I put it in my calculator, not just how I got the answer. Okay, so you'll get A10 equals 27. So we want to write a sentence that says the amount after 10 years is, because is means equals. So here's the left. Amount after 10 years equals 27%. Okay. Now this is what I believe they would ask you on the diploma, is this question right here. Determine how long it would take to the nearest tenth of a year until only 10% of the cobalt 60 remains. Okay, and don't get mixed up. That's why this is a really good example. Don't be thinking I got to put 60 in this formula. That's the name of it. Has nothing to do with any variables or anything. Okay? So the first thing we do is we write down the formula that they will give us. It's AT equals A naught. A naught means now times 1/2 to the T over 5.3. Again, looks like a pretty intimidating formula, but just take it piece by piece. Now, how much am I starting with? Okay, so what am I always starting with if it doesn't say? Always with 100%. How much am I left with? At the 10%. So that's where that goes, right? So this is amount after how many years will we have 10%? After question mark years, right? Or T amount of years. Yeah. So T amount of years. You don't have to put the percent signs in if you always know I'm going to use 10. Now some people would say, but I thought we always have to convert to decimal. So they're going to put that as 0.1 and this as 1. But it's still the same thing. You just move the decimal over 2. Okay, so you can keep it in decimals. You know, they both work. Okay, and then we put my 1/2 to the T over 5.3. Now, how am I supposed to solve this? That's why I think this would be a diploma question. Because some students would be like, I'll go with C. Okay. So, any ideas? You have to figure out T, right? When all fails you, what should you try? How could you use your calculator to solve this one? Y1, put in 10. Y2, put in 100 times 1/2 to the exponent T over 5.3. Okay, so I just want to give you guys a couple minutes. I'd like you to try it. I know some of you are like, oh, I'm enjoying watching you do it. Okay, well, you know how that goes, right? Okay, so don't even look up until you've got the answer. Who cares if you do it wrong? You will be farther ahead than the person that doesn't do it at all, because you'll figure something out. Okay, so I want to double check I got it in right. y1 I put 10, y2 I put 100 times 1/2 exponent x divided by 5.3. I hit zoom 6 and I got that useless graph right there. Okay, now after you hit zoom 6 you can hit what's called zoom 0 or zoom fit. Okay, so hit zoom fit and hit enter and see if it'll do something, so it'll make you see more of the graph. Okay, it's not always great, but it's sometimes way, way, way better. Now, what this does for me is I can sort of see where it's going to intersect. It's happening over here somewhere, isn't it? Okay, so what will I have to change? Just by looking at this. Yeah, which one? X max. So I go to window, and X max right now is 10. Okay? Okay, so let's go to 20. Okay, you can see that bottom graph just at the very, very bottom. Okay, so maybe I got it. How do I find out the answer? Second, trace, 5, enter, enter, enter. 17.6. Now is that grams? Is that years? Is it what? Years, right? Because time. We're solving that t up there. So we got x, which in our case equals t, which equals 17.6 years. Okay, so I just want to write a sentence down so we understand. It will take 17.6 years for cobalt to go to 10%. Start at 100%. After 17.6 years, 90% of it will be gone. Yeah, so you do want to draw yourself a rough graph. Okay. Whoa. What are you doing? Okay, so those are my y1, y2. There's the picture. Can't see my 10, but that's a 10. Yes? No. Okay, is this sort of making sense? Okay, let's do another one. Okay, the population of a specific bacteria is growing in a petri dish is modeled by the function. Now, just by looking at the function, can anybody tell me it's tripling every 4 years, okay? Remember, I always circle that and say it's tripling every 4 years. I can guarantee you tons of students will go to the diploma not knowing that, okay? What else can you tell me about, just by looking at the formula? Okay, I got 12,000 of them, right? So I know that it triples every 4 years, and right now I have 12,000 of them. Okay, so the first question says determine the value of t when pt equals 324,000. The value of t is what? Like what? What's the value of t? What does that mean? What are they looking for when they want this up here? Okay, the time observed or time that went by, right? Don't get it mixed up with the bottom one. This is always the time it takes to triple, or the time it would take us to do whatever's going on in the brackets. Okay, that's a 2, that'd be time to double. That's a half, that's time to half. Okay, This time stands for how long we're going to watch the thing, or how long has it been sitting there. Okay? So that's why I always get students to circle that, so they don't think that that 4 has anything to do with this t. Okay? I mean, it kind of does, like mathematically, but these two are, they're buddies, right? This is like we're going to either find this, or they're going to give this, and then they're going to find out how much we have. Okay? So this stands for what? What's 324,000? How much I will have, right? Which stands for this. So we go 324,000 equals 12,000 times 3 to the t over 4. Now, you can y1, y2 it this way. Okay? You can do that. But I got to get you ready for the Johnny Jane question. Okay? Johnny did this question, find his mistake. Okay? Will they have one of those? Guaranteed. I've never seen a diploma in my life where somebody didn't do the question, you got to find the mistake. Okay? And you got to be confident with the steps. Now, if you had to solve this algebraically, remember what you want to do is try to get this by itself. Okay? So, do you see how this is multiplying to this? The first thing we want to do is divide. And you'll see why this is a Johnny question perfectly when you see the next thing that happens. Now, what is 324,000 divided by 12,000? 27 equals 3 to the t over 4. Now again, we're not going to y1, y2. We're going to think about today's quiz. How would I have solved this on today's quiz without one? Yes? Okay, so see we have a base 3. We want to try to get 27 to the base 3. So you go 3, and you will find that this is 3 cubed equals 3 to the t over 4. Remember, this is Johnny doing it, right? Don't go, oh man, I would have y1, y2. Why is he doing that? I'm not going to do this question. It's wasting my time, okay? That's not what this is about. This is like, where do you make a mistake? Okay? Then you get to cancel these out, and then 3 equals t over 4. Then what do? Multiply both sides by 4, and you get 12 equals t. And will they have maybe E? Johnny did not make a mistake? Yes. Okay? So how would I know Johnny didn't make a mistake for sure? y1, y2 it. See if I get 12, then I'm like, yeah, he didn't make a mistake. Okay? But what if you followed them all the way through and you're like, I don't see a mistake? Okay? y1, y2 it. Plug 12 into here. See if the left side equals the right side. There is 3 or 4 ways to do this question, right? So I got 12 equals t. What's 12? Because that's another thing. People are like, oh crap, I don't even know what that number means anymore. I've been doing this question so long. 12 what? Bananas, carrots. Okay, so we got to go back up. And what was time in? Hours. Okay, so 12 hours after the initial count, right? How would you like that for a job, eh? There are now 324,000 bacteria. Okay, and then could you do this one, y1, y2, or do I need to show you? You want me to show you? Okay, so y1. Now, if you want my advice, y1 and y2 the farthest up you possibly can. Because if you say, well, I'm just going to do this step, like I'm going to do this step, and then look how small it is, but if you screw this up, now you're going to y1, y2 the wrong thing. right? So you kind of never want to y1, y2 any work that you've done unless you really are confident, right? So 324,000 over here, 12,000 times 3 to the exponent t over 4, x divided by 4. Okay, so like last one, I will just take this screenshot, so any students that are watching it see what I put in. Okay, so left side, then right side. Did I make a mistake? Oh, yeah, I wasn't even paying attention. Okay, so that's supposed to be 14,000. Doesn't make you feel better when I make mistakes, eh? Okay, so 14,000. Again, I'm just going to take a screenshot here. Now, my best advice is always go zoom 6 before you start, or else it'll try to do zoom fit from the last, whatever you had before. So I will go zoom 6. There's a very good chance I will not see anything because of the huge numbers that I put in there, but it will bring your calculator back to that, and then go zoom 0 or zoom fit. Now, 9 times out of 10, it's not going to give us the exact answer. Now, it's maybe going to intersect twice, over here and over here. Now, we're looking for time, correct? These are x values that are what? They're negative. Can't have negative time. Okay, we're not going to get it philosophical right now. Just so you know, for the diploma, you cannot have negative time. So we're going to be looking for this intersection here. So you go second trace, and you go 5, and your spider may be, see, he's actually closer to the other one. He will jump over here. So you have to, it's a very lazy spider. He will go to the easiest one, so he's closer to that one, then hit enter 3 times, and hopefully it works. Oh, it's thinking. Come on, baby, don't fail me now. All these people are watching. I have my Y2 wrong. Oh, yeah. Look. Jeez. There's like 37 of you guys. You can't find one mistake? Come on. I know. So I put division instead of exponent. See how close they are to each other? Honest mistake. I know. Okay, and I lost my bracket. Okay, let's do this again. Well, that one was right. Okay, so I'm going to go zoom 6 again. Oh, no, is that what you guys got? So it's around right there. So that whole thing about negative time, still good conversation, but not applicable here. So second trace, 5, enter, enter, enter. 0.56125, okay? No, that's right now, because I actually have this written down. You guys are shaking my confidence in you, eh? Okay, so, and this should have been an exponent. Okay, and then you get this thing. Oops. Okay, and I found the intersect right here to be 0.56 hours. And I look on the side and it's in minutes. They've got A, B, C, D all in minutes. So 0.56 hours. Now kind of think, how many minutes around? What's 0.56 of an hour? What's 0.5 of an hour? Okay, so be thinking around 30 minutes, right? Half an hour. This is 0.56 hours. Okay, but you want to multiply this by 60 minutes over 1 hour is 34 minutes. Okay, so you got to be careful. They might not always just say, or they might even, this might be a numerical response, right? One of these, how many minutes to the nearest minute? You'd put the 34 in there.
Good afternoon, everyone. Shortly we're going to have the bell for just a quick...
Okay, so I just want to quickly go to your homework. So you're going to flip a page and then flip another page, and then there's this one right here.
All students on the Student School Council, could you meet in the conference room during East? That's all students participating in the School Council. Please meet in the conference room during East.
Okay, so all I want to do is see if you can look at this and see if you could come up with the formula. Okay, now remember the formula is like y, or no, it's A T equals A naught times, this is like usually our B to the T over, usually that's doubling time, half-life, whatever, right? Okay, anything, just by reading that top, could you figure out anything that, so could this, anything that could go in there right now? Okay, time is, 24 hours does what? So every 24 hours it doubles. So where would the 24 go? In the T or the H? In the H. So right now, we should have a 2 here and a 24 here. This means every 24 hours it doubles. Okay? Now, what else do we know in this thing? Percentage. Now, is that after or now? 3% is now. Okay? So this will be the formula for this specific bacteria. Is it a bacteria? I didn't read. Mold. It's a mold. Equals 3 times 2 to the T over 24. Okay, and you're going to do some Y1, Y2 stuff with that, but it's just important that you are making this every 24 hours it doubles, right? Make sure you can always do that circle. Okay, so what are we working on? So page 151, 6, 7, and 8. Okay, and then number 3 of next page that we just started with. Okay, and that should be enough. Okay, now the period's almost done. There is going to be some stuff going, right? So go take a break, come back, and then you'll have time. You could be multitasking and working, and maybe even the last 10 minutes of East, we can get our tests back.